Okay, welcome back. We're on page 228, and I'm in the process of telling you this crazy story about cleaning data. So in this new database, what we're going to have, instead of having the soldier type in the city that they lived in, it was going to be in a little pull-down list. And so we wanted to have, the top 30 or so locations in the area, and if it wasn't in that area, they could type in something else. Okay. Well, to do that, I had to go through and clean up the other data and go and find every single misspelled word and fix it. Every place where they forgot to put in the zip code, I had to go in and fix. Every place where they messed up, got date digits backwards, I had to go and fix. The idea is that this took a heck of a lot of time to do this. To clean that data, to make it import into the new system, was a heck of a lot of work to do. And it was tedious and boring and bad. Okay. The other way you can do data cleaning, so that scenario was like in preparation for putting it into a database. That's one way. The other way is, let's say, for example, I've been doing this, I'm a small mom and pop operation, and I have sales data going back 15 years in my database. So every time I do a query on sales, it has to go through 15 years worth of data. Don't you think maybe I ought to retire some of that data? The data that really, really isn't relevant anymore. Now, I'm not talking about, deleting it. I'm talking about, moving it off to another table someplace so that my queries run faster on current data. And if I want to access the historical data, that's fine. But don't slow me down by having, a million rows in my table, when in reality I'm really only interested in the top 100,000. Okay, so data cleaning could be because I'm doing a database, or it could be because I want to speed the system up and archive some of the older systems. They talk about the as the accuracy increases, the cost of performing data cleaning to achieve 100% database accuracy could be absolutely expensive. That you're going to have to pick a number. You're going to say, look, maybe 95% is all I can afford. Because this stuff is, like I mentioned, very tedious and very painful. Okay. The next thing we're going to talk about is like the types of databases. So when it comes time to do a database, you actually have some choices. The first one is what's called a flat database. Well, I'm not doing it in particular order, but a flat database. So a flat database is not using the relational model. Okay, a flat database is, I have like Excel spreadsheets. I have an Excel spreadsheet for every month, and it has a bunch of data in it. But there's no real relationship going on. There's not like when something changes over here, it's going to automatically change over here. And yes, if I misspelled something on here, it's probably misspelled on all of them. There's no relation. There's no that entity relationship kind of thing going on. So they're just considered flat files. And there's a lot of them. Excel spreadsheets, OneNote. OneNote's great for, scribbling notes and making things. And yes, you can go through and retrieve them, but there's no real relationship going on. So these things are kind of sort of simple. It's a flat database, and I'm not saying that they're bad. They're great for doing what they're doing. But if you wanted to import them into a real database, then you're going to have some problems. So there's an awful lot of these things out there, and they're actually pretty good. They talk about QuickBooks, great. QuickBooks is actually kind of morphing into a real honest-to-God database now. They're not necessarily a flat file. So they talk about what most people would call a personal database, a single user database management system. So I'm thinking Microsoft Access because I'm a Microsoft kind of guy. But essentially, there's an awful lot of these things out there. What they're really designed for is a single person keeping data in their database. So if you're the treasurer of some, hockey club, then you have a database, talks about all your members and they've paid their dues and when the next event says. It's a pretty decent little database, but no one else uses it. Okay. Multiple user database, these are the big boys. And this is where you install it on a server somewhere and multiple people can talk to it simultaneously and everything is fine and dandy. Okay, so let's talk about some of the disadvantages. Let's say, for example, I have Microsoft Access and it was really, really, really designed to have like 1 or 2 people working on it. Okay, you could take the DBM file or the exchange, now it's a ACCDB file, and put it up on like a network share, and you could have your entire company pointing to it. And in theory, you could have like 256 people simultaneously reading and writing to that database file. Yeah, in theory. In reality, it's about a dozen or so. If you get more than a dozen folks, then that thing becomes very brittle and it'll break. Probably break a lot. And there's an awful lot of other weird things going on. While I have like the database in use, and it comes time for me to, like back up the system, I'm doing a backup of my server. When I back up that file, it's not necessarily in a consistent state when I do a backup. It's just in whatever the heck's going on at that very second. And so that's not necessarily good. So databases are single user databases typically don't have a very robust, user kind of a scenario. I mean, yes, you can do it, but they don't, by default, they don't typically say, well, this person has read access, this person doesn't. They don't typically have that good of concurrency control, and we'll talk about what that means. And they certainly don't have a very good system of doing backup and restore, bring me back to the way I was yesterday, that kind of stuff. Multiple user databases, they have all those things. By default, they have individual users and individual permissions and ways that you can do backup and recovery. Okay. There's some more out there, and they get a little bit bizarre. And so, SQL databases, structured query language. By the way, we have an entire class on doing database design. We have an entire class on doing structured query language. So, like I said, this is like one chapter in a book, right? So I'm not going to go into too much detail. But anyway, structured query language is all about how to do, and here's some cool things. They talk about the ACID principle. And ACID means atomic, which means when I save something, it's going to make sure that it happens in one step, and then when that step is complete, you're assured there's nothing hanging out there. The thing I was talking about, making sure the database is in a usable state. For example, when I'm performing a backup, I want to make sure that it's in a stable state. That's what that does. Consistency. Isolation, which means no one else can see what else is going on. That a transaction shouldn't depend on some other transaction. And then durability. These are these 3 terms. And typically only the big systems, not the flat files and not the personal databases, they do this well. That's what they were designed to do. Okay. This is kind of boring, but if you're into that, a SQL command, select client from, client table where debt greater than 1,000. Again, this is not a SQL course. I'm not going to ask you any questions about, how to compose a SQL score. Okay, so we're skipping that part. And going on to different database types. So there is a movement out there called NoSQL. Now, a lot of people look at that and went, yeah, because I don't want to learn SQL. No, that's not what NO stands for. If you actually look it up, NO stands for not only, not no SQL, not like, well, there's no SQL going on. Okay, so what this has basically done, remember that relational model where it showed where it had 3 tables and they were combined together to make one giant result? Remember all that? It was just a couple minutes ago. That's actually kind of complex, isn't it? I mean, just reading about it, that's kind of complex to set up. Now, admittedly, it's utterly brilliant. It makes sure that everything is perfect and that you're not going to have any data corruption and you're not going to have any duplicates. I mean, it's a fantastic system. However, it is complex. And sometimes you need speed and simplicity over all those things. So you're willing to not have it be, the ACID principle. You're not. It's okay for it not to be durable, or not to have isolation, or not to have consistency, or not to have a atomic operation. That's perfectly okay. I'm willing to sacrifice all the good things in SQL just so I can just handle either a huge volume of data or a huge quantity of data. So sometimes the data is just too big or too fast for me to do it the way I really want to. And that's what NoSQL is all about. Okay. So, yes, there is a price to pay for having a relational data model. If you're using the relational data model, yeah, it means your computer has to be pretty robust, and yeah, there's some complex things that has to happen. I mean, don't get me wrong. It's everyone who uses NoSQL really would prefer not to. Okay, you're using NoSQL because you just can't. All right, your first choice would always be, well, let's put it in the SQL database, and only if it don't fit, then you decide to do these guys. Okay, so these are highly scalable and hundreds of thousands of databases and transactions. There's a cool little thing here coming up talking about the amount of volume like it gets generated by YouTube or Twitter. Okay, Hadoop. This is one of those crazy terms, and you may have, if you're in the business, you've heard of this. It's basically an open source framework showing you how you can put together storing extremely large data. So again, eBay and Twitter and all these folks are using these for big data. And the idea is, yes, they would love to use traditional SQL, but they just flat can't. Okay, and here's some examples of some of those types of databases where you might want to go slightly different. All right, binary data. Let's say I have images. I've got X-ray images I'm storing in a database, or maybe I've got pictures stored in a database, or maybe I'm YouTube and I've got videos stored in maybe I'm iTunes and I have music stored in a database. So we're not talking about numbers and letters, right? We're not talking about street addresses and zip codes and tiny little fields that are just take up a few bytes. We're talking about huge things that could be in a database, and so you need a different style of database to be able to handle big things. The other one to talk about is spatial database. This is the kind of stuff that, like, using your sat-nav system. Your sat-nav system has a database of all the streets and their names and how they're connected and points of interest. And so this is what's called a spatial database, because every little point along a road, it knows its latitude and longitude on each one of those things. Okay, so those are kind of the database types. All right, so the next thing we're going to learn about is what the typical database activities are. So what is my database supposed to do for me? And we kind of mentioned this at the beginning. The first one is providing the database, to the human. So I have to have some way of presenting the database to the user. Now here's where things get a little complex, because they use this term schema, and I'll go ahead and jump into that. But unfortunately, schema is used differently by different database vendors. I know it sounds crazy. If you're in the Oracle world, the schema is essentially like the user's preference view. It's a list of the things that they can see and how they've got set up. It's sort of like your user profile, okay, in the Oracle world. In practically all the rest of the database worlds, the schema is used to say, this is what describes the database. It tells about what the tables are and what the relationships are. And I'm going to use that version of schema. Okay. Whew. All right. So, first one is providing some sort of a view. That makes sense. The next one is I need to go in and add and modify things. So I need to provide a technique. Instead of just looking, I need to have a technique for adding and deleting and modifying. That makes kind of sense. Storing and retrieving is kind of next. I need to be able to store the data in there and be able to figure out how to pull it back. And then lastly, I need to be able to produce reports. And this is a good place to stop for the 15-minute mark. We'll pick this thing up again in just a few.